Hi everybody, my name is Dalibor Topić. As you can see, I'm from Germany. I'm German, I work for Oracle Global Services Germany in Hamburg, but our soccer teams are nowhere near as good as yours here. So, we can only watch and envy as you guys rock the Champions League. My job is, I'm a product manager in the Java Platform Group. It's a bit weird because I don't have a product to manage. I actually work in OpenJDK most of my time. I'm on Twitter, and I'm here to talk about JDK 13, 14, and all that good stuff. So before I get started, I work for Oracle, so we have a safe harbor statement. Those of you who have seen the talk of my colleagues, you know what it's like. If you don't enjoy it for a moment, I'll enjoy a bit of water. And I'm sure you're all fast readers. Basically, don't trust a word of what I say. All right. Now, the first thing I want to tell you is that JDK 13 is actually here. It was released last week during the Oracle Open World and Code 1 in San Francisco. And it was released on time. This is the fourth such release in this new release cadence where we have a release every 6 months. And each one of them has surprisingly come out on time. Back in the good old days of Java 6 and 7 and 8, and 9, that didn't actually used to be the case, but now it is. And you can get it in two ways. You can get the Oracle JDK under commercial license from oracle.com, from the Oracle Technology Network, or you can get the Oracle OpenJDK binaries under an open source license at jdkjava.net. And having these two different offerings as part of the 6 monthly cadence lets us satisfy both the needs of commercial customers of Oracle who want to have a commercially supported product, but also offer an open source build for the whole developer community that then gets updated every 6 months with the next release. And for those customers that need to have something that's available for a longer period of time, who have applications that need to run for until 2025 on Java 8 or something like that, we offer something called long-term support. And there is a long-term support release coming out every 3 years, so that then enterprise users, for example, can move from one long-term support version to the next at their own leisure. And to do so, we offer a commercial Java SE subscription, which provides such support for desktop servers and cloud deployments, and gives you access to ongoing security and other updates straight from Oracle for as long as the release is supported, including even interim releases for fixes that are critical for some customers that can't wait until the next update release. That's available through Oracle, 24/7, many languages and so forth, along with various monitoring and enterprise deployment features. That being said, what is in JDK 13? So JDK 13, with this new cadence, the releases actually take about 9 months to make. And so we started last year in December, and all in all, it ended up having 5 major features. And as is the case for these feature releases, it's all across the board. There is VM features in there is language features in there is a library feature in there, and that's just the tip of the iceberg. There's a lot of other stuff under the hood that I'll mention in a bit later. The funny thing for us is, of course, that we all have these schedules we publish, and we manage to hit them. That's great. Shipping stuff every 6 months is awesome. The other good thing about shipping stuff every 6 months is that it's a lot less to ship. So in economic platform theory, there is something called the penguin effect. So it's a story about how, after a long winter, all the penguins are starving, and they want to go out in the ocean and eat the fish and all that stuff, but there are predators in there. Nobody wants to be first. So everybody wants to wait and see that somebody else gets eaten first. But if you wait too long, all the fish is gone. So with software, people also tend to upgrade with those big releases, but tend to wait a bit and to see if somebody else maybe falls into a trap and has to update all that stuff. And in the good old days of Java 8 and Java 9, those releases tend to have a lot of features built in. So we were at around 60 JEPs for JDK 8, around 90 for JDK 9, and that means that for enterprise customers, they will look at this and go say, yeah, Lambda's cool, or yeah, modules, but I think I'll wait a bit. Maybe there is something among these 90 features that's going to negatively impact my applications. I'll just wait for a while. And these shorter release cycles lead to much smaller releases overall. So on average, we had around 10 to 12 features since JDK 10 per release. And that means there's a lot less for you in terms of risk to have to consider. And so our experience, where we talk to more than 100 open source projects out there in the community that have been able to build and test their code in latest versions, is that once they get to that point where the code works and runs well in JDK 11, for example, then being able to move from JDK 11 to 12 to 13 along with this cadence is no longer nearly as much of a challenge as such moves used to be. And that's something that I think is very valuable for customers, because it lets them actually have a much better understanding of how much effort to budget for in terms of migrations than was the case before. And all of this stuff is happening in the open, in OpenJDK, where we work on the reference implementations. Oracle, of course, being the steward of Java, does a lion's share of bug fixing and features and all that, but we're not alone in this. Oracle, along with other organizations, companies, individuals, is working on various aspects of the JDK. The JDK is really big. There's the VM, the class libraries, individual features, ports, and so forth. So that, for example, for the 64-bit ARM CPU port, a lot of that support has actually been driven and come from small companies like Ampere Computing, big companies like ARM, and everybody in between, from Red Hat to Bellsoft and so forth. And so the OpenJDK community is an excellent example of open source actually working really well in practice and letting us deliver those 6 monthly releases packed with good stuff in them at a high quality level too. And this has in fact been increasing from release to release, so we've seen more and more participation out there from various organizations coming into OpenJDK itself. But also, I'd like to point out that the overall scope of releases has remained really high. Each of these 6 monthly releases has thousands of bug fixes in them. So they're actually quite huge improvements in and of themselves. Okay, so much to give like a taste of why we're doing this and why it's working. What's actually in 13? So on the language side, we have this new feature called switch expressions. And in fact, if you've listened to one of the talks from like half a year ago about JDK 12, you would have heard something about switch expressions as well. They were there already as a preview. And they're still there as a preview in 13. But there is one small change. We have added a yield statement to return a value from a switch expression based on feedback we received in the time frame of JDK 12. And that's the reason for the preview features. So this is a language features that's available for you to try out and let us know if it meets your needs, and where it doesn't, let us know in particular about that, so we can adjust it and make sure we can deliver something that really makes your life easier as developers. And what this feature is supposed to do is supposed to simplify everyday coding with switch statements by letting you use them both as regular statements as well as expressions, and providing a simplified scoping control flow form, which sounds like a mouthful but looks much better on slides. So imagine you have been tasked to write a not very useful method that tries to compute the number of letters in a day's name. So you would maybe have something like this: a switch over a day, and then case if it's Monday or Tuesday, or Monday or Friday or Sunday, it's 6, and so forth. Tuesday it's 7, yada, 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 all the way through. This is what you would write back in the old days. With 13, you can actually use this new form and end up with something that's much more concise and much more readable, by first being able to enumerate the different cases that you handle and handle them in a single expression by using the arrow symbol here. And the nice thing is you don't have to put breaks in there. And that's very important, because that's super confusing for beginners. Because if you forget to put a break in there in the good old days, then the switch statement just falls through and continues executing. And that's a source of all kinds of fascinating bugs. So you don't want to do that. You want to use this, in particular if you're teaching Java to new developers, right? So no fall through, it's good. And then the other thing is, imagine that, all right, so you've been printing these letters out, great, but nobody really reads your logs. So what you really want to have is you want to have a function, right, that you call, and then it computes the number of letters in a day. So you would define a variable and then set it according to the switch statement somehow. It's also very complicated. Or you could use the switch statement as a function, and then just initialize the variable letters by the number of letters in a day. And that's again much simpler, much more obviously right than in the other case. And then if your actual expression is more complicated, you can use the yield statement to return results from it that you compute. And so you can have a complex computation on the left, or you can have various different return values for a switch statement depending on various case statements. which again I think is more readable than it would have been before. But keep in mind, this is a preview feature. So it's fully implemented, fully specified, but it's not necessarily permanent. It can change from release to release. And that means in order to use it, you have to both tell the compiler, yes, I want to use preview features by passing the enable preview flag, but also you have to tell the JVM that yes, you want to use code that's compiled with a preview feature on it by passing the same flag to it. And that'll just do the right thing. Okay, switch expressions, I think are obviously neat for people writing that kind of code. Text blocks are another feature in 13 that's maybe obviously neat for people who have to deal with other people's languages or materials in their code. Sometimes we write code that has to basically deal with text blocks that express like HTML code or SQL code, JavaScript, whatever, that you, for example, try to output from your code. And with this feature, we actually have a way to express multi-line strings so that you don't have to do all the manual formatting yourselves. The compiler does this for you. And again, this is best illustrated with a picture. So instead of, in the good old days, being able to, or writing, an HTML string and assembling it manually and inserting return carriage characters manually, you can now use the triple quote and the compiler would verbatim copy the actual string in there. And it'll take care of indenting it properly as well, which is quite nice when you're dealing with, say, code inside functions. Because then a lot of this gobbledygook and escape sequences and, oh my God, how do I make the JavaScript escaping match with the Java escaping? All of that stuff kind of goes away, which is kind of nice. Again, this is a preview feature, so you have to tell the compiler and the VM that you really want to use it, and then it'll do the right thing. On the library side, we have one interesting feature in 13, which is we have gone and used the new I/O API from Java 5 to re-implement sockets, so that the implementation in 13 will actually delegate to that. That's kind of nice for two reasons. One, we can get rid of C code, and whenever we can get rid of C code, that's awesome in the Java library because it's faster, easier to debug, and so forth. But also, it prepares us for fibers for the world of Project Loom, and that's quite nice. So, long story short, with the 13, your sockets should be more efficient and scale better. But in case you run into any kind of issues, our philosophy is to give you ways to go back in time. So there's a setting that says you can use the JDK net use plain socket impl property to go back to the implementation. And of course, if you encounter any issues, let us know about that so we can fix them. The ZUC garbage collector is something we introduced a while ago. It's a garbage collector for really large memory situations. And sometimes you have applications that run, for example, do a lot of work up front, but then reach a stable state and just hang around there processing a bit of information every now and then, or that are run in clouds where you have to pay for your memory. And so what you really want to do is you want to, over time, make sure your application uses only as much memory as it really needs. And so the garbage collectors, like G1, for example, have this capability to give back memory to the OS they don't need anymore. And ZUC has the same sort of thing enabled by default now in 13. And of course, again, you can turn it off if you really want to pay for all that memory, which is fine, right? That's your choice. And then one big area of improvement has been startup. Startup is something we've been working on for basically forever. But since 8, it's been receiving a lot of attention on our side because, of course, with the move towards cloud, all the work you do extra that doesn't run your code is basically money you pay for not running your code. So you want to reduce that startup as much as possible. And we have done that in a bunch of ways in past releases. One is through class data sharing, which is a feature that lets the VM basically dump a preloaded form of your classes and libraries to disk, and then quickly load it up again. We've extended that to support applications a while ago, and made it on by default, so you don't have to do anything with switches. And now with 13, the feature is being expanded to cover basically all application situation, all your class loaders and so forth, so that they can, when you have dynamic applications, you can just pass in a switch called archive classes at exit, and give it a file name, and it will just generate a whole archive of all the classes and libraries applications loaded, so that next time you start it up, it will just fire it up with that stuff preloaded, which then, again, cuts your startup time. And this is kind of nice in some situation because you can improve your memory and startup and so forth. You can find all that stuff in the JEP itself. Right, and there is a whole bunch of other stuff in 13, of course, that I won't go into because 2,000 changes or 3,000 changes, it's a lot of stuff, right? But what I want to say in general is that, as with every release now, we remove some internal stuff that's no longer necessary for JDK. We deprecate some other stuff, such as, for example, the options nobody should use, like no verify. Don't do that, right? It's now deprecated, you get a warning message. And we also add in upgrade usual things like Unicode and CLDR and so forth. All of this stuff is in release notes. So even though the releases are smaller, please make sure you read the release notes anyway. You learn something that way. And speaking of learning something, we've also learned that people have started to care about 14 already, because we just shipped 13 last week when we thought we were done, right? But no, we've been working on 13 for the past couple of months. And now that 13 is out there, 14 is now receiving a lot more attention. And so last week, Mark Reinhold, who is our chief architect for the Java platform, has proposed a schedule for 14, which again calls for a beginning of ramp down before Christmas, and then a release candidate in February, and a release by the time of St. Patrick's Day. Weird how that comes out. I mean, I'm always surprised how we managed to actually release in September around the time of Oktoberfest. I have no idea how that works. Anyhow, there's always something to celebrate. With 14 having just been started, we don't have that many features to talk about. There's just one that's already been targeted. It's a JEP for non-volatile mapped byte buffers, and that sounds like quite a mouthful. Basically, what it's all about is we have extended the file channel APIs in NIO to be able to create mapped byte buffers that can then read and write synchronously to non-volatile memory, which is really nice if you need it. If you don't know what it is, fine, it's okay. Don't worry. The thing is, this is basically an OS level feature and CPU level feature, so it requires support from both the operating system with the memmap call with specific flag and the CPU, so it's only available right now on Linux, 64-bit Intel and 64-bit ARM. I think Windows has the same flag for mmap, so it may be something we'll look into, but it's not there in 14 right now. Right, and then the process we have is that new features get proposed for inclusion into release, and they get discussed, and then if everybody says cool or not so cool, they go in or not. And so one that's been proposed last week is helpful null pointer exceptions. And when has a null pointer exception ever not been helpful, right? All right, sorry, joke. This is actually a feature that comes from the SAP JVM team that have been using quite successfully with their deployments. And the goal here is to improve the usability of null point exceptions to tell you what it is that is null, actually, right? It would be nice to know without having to go to the debugger. And so, for example, if you have a code that says, A.I is 99 and A is null, it would be nice if the exception actually said, hey, I cannot assign field I because A is null. Because they could save like a round trip to the debugger, right? So that's nice. But of course, that may be kind of obvious in this case. In some other cases, though, if you have like an array of an array of an array of an array, then actually knowing which one of these things is null is really useful. And so this has actually been proposed for inclusion to 14. I hope it goes in. And it's a really nice implementation because contrary what you would naively expect, that this code basically requires you to go and munch bytecode and have a Java agent running to like put in extra bytecode around your code to create all these messages. All this magic happens inside the JVM. So it goes and at runtime computes the message by going through the bytecode access paths. And that's why it's efficient. It doesn't require to recompile anything. It just works out of the box. Unless you're using RMI serialization, but nobody does that, right? And if you want to know why that is, read the JEP. Okay, and if you want to know what else might be coming, the process has candidates. So before something is proposed, it's going to be a candidate. And all of that stuff gets posted to our OpenJDK Twitter feed, where you can simply subscribe and follow along as this stuff happens. Or, of course, you can follow along on the mailing list, but who uses email these days, right? Okay, we do. We do a lot of email in our open source projects. And OpenJDK isn't just the JDK itself, it's a whole host of other things we do. And some of these things end up being features that go into new releases, such as these switch expressions, for example. Others are things that are more experimental in nature. So I've thrown a couple of these things that I've been working on for the past couple of years, really. One of them is Project Portola. Portola is a port, as the name sort of implies, of the JDK to the Alpine Linux platform. Alpine Linux is a Linux distribution that uses its own C library that's very compact, and that way lets us basically produce really slim container images of the JDK that are basically tens of megabytes instead of hundreds. So it's currently a project of its own, and there is now a draft chap to maybe include it into mainline in the future revision. So if you're interested in say, minimal Java deployments in Docker, that's something to look at. We also provide early access builds of Alpine OpenJDK binaries from Oracle. Then Project Valhalla is a project to both look at the language side of things and the VM side of things of data representations. And when you have, for example, arrays of complex classes, this is not a very complex class, but let's say we have an array of that, then of course the array will have pointers, we'll have more pointers to more instances of classes, and all of these things will have headers, will lie around all over the memory and so forth, keep the garbage collector busy, which is great, but it would be even great if we had a way to say, I want to have like a valid value type, a type that's actually, that the VM understands that it should represent compactly in arrays. And so that all of the header information that's not necessary for my accesses is elided, and these things are laid out continuously in memory, which makes things faster and more efficient, not just in terms of memory pressure, but also in terms of access. So that project's also been quite active, has produced a number of early access builds. You can try them out and give us feedback on that. Project Panama is very interesting because it tries to bridge the gap between Java code and native code. And I mean, you spoke earlier about OpenCV, which is a library that has a significant native part, for example, written in a different language. And of course, as we deal with different operating systems, there are always components that are not written in Java, but it's something else. And to access them today, you have to write JNI, for example, and everybody loves to write JNI. Has anybody here written JNI? Good, let's keep it that way. That's what Project Panama is for, right? So if you want to access some random JNI library, you can do this through Java itself, and it takes care of generating the glue code for it. Again, here we have prototypes for you to try out and give us feedback on. Project Loom, I mentioned before, is a project to make concurrency simple again, as Ron Pressel likes to put it, to basically provide lightweight threads within the VM itself, because right now we delegate threads to the operating system, and they can be quite expensive in terms of tear up and tear down. And with lightweight threads within the VM would take care of spawning and up, scheduling them, allowing us to have basically millions of fibers in a single JVM instance, which is nice from a memory and scalability point of view. Project Ember is a project to make small language changes, which has delivered a bunch of things already, like the var keyword in 10, or the switch expressions in 12 and 13. There's a bunch of other things we're working on here. Most importantly, I think pattern matching to, again, make code more concise and simpler to use. Project Scara is a project that's actually not delivering any features. So it's actually a project that's delivering Git to OpenJDK, because OpenJDK, having been started more than 10 years ago by Sun, uses some idiosyncratic tools to manage itself. Not just that we have our own unit testing frameworks, no, we use Mercurial to manage our source code. And it turns out that in the past 10 or so years, most people have become familiar with Git and GitHub and all that, and there is no Mercurial hub, so yeah, what you gonna do? We've looked at various options, in particular because the JDK source code has become so big over time that we really need to move off Mercurial. And it sounds like we'll probably end up settling on Git. We're trying out this workflows on a bunch of projects on GitHub. So if you have a GitHub account, you can follow, for example, Loom. You can follow OpenJFX and a bunch of other projects on the OpenJDK GitHub organizations and send us your pull requests, right? And our goal here is really to make OpenJDK more productive for new contributors who are really coming new to this organization, maybe even new to open source, and not just veterans of Java. So all that being said, there's a lot of stuff going on. We have these releases, so we deliver innovation regularly. We have a new one in the pipe. We have update releases, also like a meat factory. But we also have all this forward-looking stuff that I think is very exciting and could deliver some really nice features over the next releases for all of us. If you want to start playing with this stuff already and be ahead of everybody else on your block, you can go to jdkjava.net and then get their early access binaries for Valhalla, Panama, and JPackage I didn't mention. That's a tool to actually package applications app along with their runtimes and create installers for different operating systems like OS X or Windows or Linux or what have you. So if you're looking, for example, to deliver native packages to your customers, that may be something to look at. Again, early access, so not a product, right? Not part of JDK yet, but we would appreciate your feedback on your real-world use cases. And with that being said, I think my 30 minutes are pretty much up. So, right, that's all. Any questions?
I'll start with the first question. Do you have any inside information what is going to be with the Swing, since I saw some AWT packages were deprecated or discarded at all? And what about the JavaFX, since it has been removed to be a separate library? Do you have any insights about that?
Right, so what was deprecated is the AWT Toolkit property, which is something you would only use if you were writing your own AWT toolkits. Is anybody here writing AWT toolkits? Right. So don't worry in that sense. Swing, of course, is being maintained and continues to be maintained. It will continue to support it for our customers and so forth. OpenJFX has been spun out, as you said, from Oracle JDK binaries into its own set of libraries that I think now more easily accessible than ever through Maven Central, which I think has also been a benefit of that community because now OpenJFX can be released on its own schedule. So it doesn't have to be in this lockstep with the JDK, and there is a non-trivial overhead about being lockstep in JDK. So I think those things are things we had to do for a long while, but we haven't done, and we use the opportunity with 11 to actually make these changes. And I think they're now gradually actually starting to come to fruition, but they're of course they take a bit of getting used to. Yes. Very good.
One simple question. You showed that simple way of concatenating strings without explicitly saying \n and the blocks. So I'm just wondering, since you're not explicitly saying how to make new lines, is it implicit that it's \n without \r, or is it dependent on the file which you are actually then compiling? So based on whether you're not on Linux or Unix or Windows, it's your strings will end up with different number of characters in the end.
No, that shouldn't be the case. But I cannot necessarily swear on it, so please read the JEP. It should have all this information in there. That's a nice thing about JEPs. They're not just, overall descriptions of what things should be. They tend to be also very technical descriptions of how things are implemented.
Okay, thanks.
Can we also vote on which features get added first in the next release?
Well, you can provide your own features. That's the way to vote.
No worries then.
It's always hard to tell other people what to do, right? But it's easy to, within your organization, say, we need X, so we're going to work on X. And is this a good fit or not, right? That's why we really try to encourage organizations that rely heavily on Java development to actually come and participate in OpenJDK in various ways. And if you have questions about it, let me know. Send me an email, ping me on Twitter. I'll be happy to help. If there is nothing else, I'll be around all afternoon. Come up to me, ask me questions. Otherwise, I'll let you have your coffee. You've deserved it. And thanks for listening.